Good morning, Year 12 further mathematicians. Just going to continue with this very long chapter on integration. I hope you're all well. 11.8 is to do with finding areas or definite integration when you've got limits. The main objective today is to be able to use or select the correct integration technique, and we've learned lots of them over the last few weeks to find areas between curves and lines. So you're going to have to select the correct method, which is the hardest thing for today. The actual techniques themselves are okay, but working out which one you need to do is the tough bit. So I'm just going to run through two reminders. First thing is about area and what you need to do. So imagine I've got just an x-axis and a y-axis like so. And I draw a curve, just generic curve. Call that f of x, and I pick two x values, a and b, and I want to work out the area of that region. The way to do that is using definite integration and say that that area there is integrating whatever function or curve we've got with respect to x between a and b. And that would be the start. Then secondly, we have, imagine now another type of sketch, like so, x-axis, y-axis, but we've got two different curves. See that curve, and then let's have that straight line there. Okay, so we've got y is equal to f of x is the curve, y is equal to g of x is the straight line. And the key things you'd have to know is what these intersections are. So I'll call that one A, that one B, and that one C. If I asked you to work at the area of that region there, any ideas on how you would do it? Now there are at least two ways to do it, but the shortcut is the top curve, which in this case is f of x, subtract the bottom curve, which in this case is g of x, and then you integrate that. So you take the top curve, which is f of x, you subtract the bottom curve, g of x, and you integrate with respect to x, with these being your limits. If you got these the wrong way round, all that would happen is you'd get a negative answer. The answer would be, if you ignore the sign, would be correct, but it'd just be negative. If you want everything to be positive, you have to do top, take away bottom. This one, or this B. This time the top curve is g of x, subtract f of x, and then you're integrating with respect to x, but now between b and c. And that would be it. Okay, so that's a reminder, first reminder. Now we're going to move on to the second reminder, which is the bigger one, which is the different integration techniques we've done up to this point. So you've got, firstly, your year one. So year one book, so the AS book, integration stuff. Just basic integration, integrating x to a power. And then you've got the stuff which we did in the start of this chapter. So I'll try and show you that. Calling integrating standard functions. So all of those, you need to know those. So standard functions. Then we've got stuff like reverse chain rule, which is pretty much when we make a good guess. So guess answers. We kind of link stuff to 1 over with maybe with logs, or if you've got maybe sine of 3x, you can connect that to other stuff and so on. Other stuff we've done, there's two major patterns. Okay, one pattern is integrating f dashed of x over f of x with respect to x, and there's a very specific guess you do for that. Okay, so that's when you guess y is equal to ln f of x. And then there's another pattern you need to be aware of or trying to spot is f of x to the power of n times by f dashed of x. And for this pattern, you always guess f of x to the power of n plus 1. Those are two patterns. Other things we've done, we've used substitution, integration by substitution. That's normally given to us. So they might prompt us and say use an appropriate substitution. Let's say use this substitution, so we need to be aware of that. We've done integration by parts. So integration by parts involves using a formula to rewrite an integration into something we can integrate. Again, that's not the easiest one to spot. Hopefully it'll give us a clue on that, but there's a formula in the book for that one. And that's also called a reverse product rule. It's derived from the product rule in differentiation. And what other stuff have we done? The most recent stuff, I guess, with partial fractions. So you've got all of these different techniques, and it's not obvious which one to do. You always want to kind of move towards the top of this list, where we're always doing these different patterns and these different methods to end up with standard functions or year one integration stuff, or maybe some basic reverse chain rule questions, but we sometimes have to use these more complicated stuff to end up there. These are definitely easier at the top. These are the harder ones. We're always trying to move stuff up this ladder and then end up integrating standard functions or using reverse chain rule. Okay, 8 minutes in and we haven't done any questions yet, so I'm going to quickly move on to what we need to do next. So we are going to do 2 examples of some integration to find different areas. So use integration to find the area of this region R. We've got a curve, y is equal to 9 over root 4 plus 3x, and area R, based on some of the reminders we've just done, would be integrating the curve with respect to x between 0 and 4. And that would, believe it or not, get you a mark in an exam. And now we have to integrate, we have to spot the right technique to use. So for me, I'm seeing like 1 over, sometimes like, is that logs? But no, it would have to be to the power of 1. This is to, it's going to be like to the power of a half on the bottom. So the best thing to do for this is write it in index form. So this is integrating between 0 and 4 of 9, 4 plus 3x to the power of minus a half dx. And then this is one of our kind of reverse chain rule questions where we add 1 to the power, divide by the new power. So I would guess y is equal to, let's add 1 to the power to this. I'll keep the 9 in there. Why not? 4 plus 3x to the power of a half. Let's see how bad this guess is. dy by dx would be, bring the power down. So 9 over 2. Knock 1 off the power. Minus a half. But then remember the chain rule makes you times by this thing differentiated. So times in by 3. So that would simplify to 27 over 2. 4 plus 3x to the power of minus a half. I didn't want 27 over 2, I wanted 9. So let's see what I have to do for that. I would have to okay, let's go back up to that. Let's call that area of R again. So my guess gives me 27 over 2 and I want 9. So I would have to times by 2 and divide by 3. Yep. So 2/3 of my guess to the power of a half. And that's between the limits of 0 and 4. Okay, so that's pretty much the integration part done. Now you have to just substitute the limits. I could simplify this, maybe just do that. That goes into that 3 times, so that's 6 of those. So this would be equal to, put the upper limit in first, which would be 6 lots of 4 plus 3 4s to the power of a half. Subtract 6 lots of 4 plus 3 zeros to the power of a half, and type that into my calculator. So 6, 4 plus 3 to the power of a half. Subtract 6 brackets, 4 plus 3 zeros to the power of a half. Going to give me 12. Because it's an area, I might write unit squared. And that would be it. Okay. I can always use my calculator if you've got one of the fancier calculators to check the integration. So check to see how bad this is. Hopefully I've done it right. Between 0 and 4. Between 0 and 4. Yeah, so that's what that one's done. Okay, keep going. So last example for today, easy number 2. It's going to be the trickiest one. So we have to use integration to find the area R, which is an area trapped between 2 curves. So the first thing you should do is get an easy method mark, which is top curve subtract bottom curve. So we are going to integrate. Top curve is f of x, bottom curve is g of x, with respect to x, between 0 and pi by 2. Okay, they tell me what f of x is, they tell me what g of x is, so area equals that. Substitute those in, so we got sine 2x minus sine x cos squared x dx. Okay, I'm going to split these up. I feel like that's going to make this question a little bit easier. Right, this one, if I show you back those different techniques, that one there, integrating sine 2x, is a combination of these standard functions and a bit of reverse chain rule. Okay, so you should know that if you integrate sine, it goes to minus cos, and because it's sine 2x, you'd have to divide by 2 as well. So I'd go to minus cos 2x, divide by 2, so minus a half, like so. Now this is the problem one. So all of those techniques we've done, you know, it could be, it's not going to be partial fractions, obviously. Integration by parts, it's a product, but no, I'm not feeling integration by parts for this one. Integration by substitution, to be fair, it's not that complicated. It's just sine x's and cos x's, so maybe not for that. But maybe one of these patterns, okay? I'm going to rule out that one because there's no fraction, but if you look at this pattern, something to the power of n times by its thing differentiated, we do have that cos squared x, cos x squared, and sine x is kind of it differentiated. So I'm going to actually try and use that pattern. So this is going to guess y is equal to cos x cubed. Let's differentiate, see how bad the guess is. Equal to 3, bring the power down, knock one off the power. So 3 cos x squared. And then you've got to times by that thing differentiated. And cos x differentiates to minus sine x. So that's minus 3 cos squared x sine x, which is very close to this. Okay, so let's continue. That's equal to minus a half cos 2x, and then my guess is out by a factor of negative 3, so I have to divide by minus a third. Sorry, divide by minus 3, so it would be my guess, which is cos cubed x divided by minus 3, like that, between the limits 0 and pi by 2. You could simplify this bit, but I'm not even going to bother doing that. I'm just going to type it into my calculator. This is equal to minus a half cos, make sure your calculator's in radian mode, otherwise you are going to get all of this wrong. Calculator should be in radian mode by default effectively. The only time you take it out of radian mode is if you're doing mechanics maybe, or they tell you the question's in degrees. Okay, this is not the easiest one to type in. Might do it in 2 steps actually. So first bit's a half, subtract, now change all of those to zeros. Subtract minus 1/6, so 1/2, subtract that answer, gives me 2/3 unit squared. It's a positive number, so it could be right. Let's see, type in the original, integrate sine 2x, subtract sine x cos x squared between 0 and pi by 2. Moment of truth. Calculator's going to take some time to think about it. 2/3. Okay, got it right. Now, I'm going to set you a few questions to do from this. So if you find exercise, let me get this right, 11H, which is on page 314. And you're going to do questions 3, 4, 6, and 7. You're going to upload your answers to class notebook, and you are going to ask for help if needed. And that's it. See you soon.